Today in class we worked on multiplication of numbers in exponential form. So we want to write each expression using the fewest number of bases possible. One of the most important things to remember is that we have to be sure that the base of each term is the same. So if we take a look at the examples in these on this page, in the first one we do have -7 and -7 as our base. And when we're multiplying the same base, we can actually add the exponent. So we're going to go ahead and write the base of -7, and then we're going to write the exponent of 3 plus 4. At a later time, we will continue to move on and be able to write it as -7 to the 7th power. But for now, I want to see the addition problem as the exponent. The next problem is the same. We have a base of x and x. So we can write this as x to the 5 plus 6. And finally, even though we have fractions, the same rule, 2/3 as my base. Don't forget the parentheses, and then 7 plus 5. Another type of problem we're going to be looking at is what happens if we have bases that are not the same. Sometimes there's nothing we can do. In this case, there is some hope. For this problem, I know that 8 equals 2 to the 3rd power. So I can transform the 8 to have a base of 2. So if I know that 8 equals 2 times 2 times 2, that means that 8 equals 2 to the 3rd power. Well, that means 8 squared equals 2 to the 3rd power times 2 to the 3rd power, because there's 2 of them. And then I also know that 8 squared would be 2 to the 3 plus 3, or 2 to the 6th. So now I can rewrite my original problem, 2 to the 4th times 2 to the 6th, which equals 2 to the 4 plus 6. So once again, identifying if a base can be rewritten to have a common base. This one looks confusing at the start, but it's important for us to see that there's 2 different bases, and I can reorder them so that similar bases are together, because this is multiplication right here, and this is multiplication, and this is multiplication. The commutative property of multiplication says I can reorder them. So I'm going to say A times A to the 4th times B to the 3rd times B to the 5th. So notice I'm just reordering so that the A's are together and the B's are together. Well, one thing that's important to remember is a letter all by itself actually does have the exponent of 1. So I can rewrite A to the 1 plus 4 power times B to the 3 plus 5. Another type of problem we'll see is when we're dealing with division instead of multiplication. When the bases are the same for division problems, I can subtract the exponent. So when we're multiplying bases, we add exponents. When we're dividing similar bases, we subtract. So I can simply write this as -3 to the 5 minus 2. Now down here we've got one little added letter or variable that we just don't need to focus on. We're going to focus on these bases that are the same. So I'm going to still have A squared, but then I'm also going to multiply that by B to the 5th over B to the 2nd power. And we know that we can subtract the exponent since we're dividing similar bases, and I would get B to the 5 minus 2. The last problem we're going to look at that will hopefully not be an issue for you on your homework is the one where we just have a regular number with no exponential value. The number 27 is the same as 3 times 3 times 3, or 3 to the 3rd power. So I can rewrite my problem 3 to the 3rd power over 3 to the 2nd. And because I know I can subtract the exponents, I will get 3 to the 3 minus 2. Thank you for watching this homework video. Hopefully it helps you get your homework done correctly.